Hello, the topic for this video is hydraulics, and we're going to look at how hydraulic systems can be used to help with increasing force using a particular calculation. But to start us off with, this be nice and simple. We've got a example of a syringe here. I'm sure you've all seen a syringe before, but basically this is a plastic little device where you can fill it with water, and if you were to then take the plunger part of the syringe and push down, you know that water would squirt out of the other end. But what we can also do, apart from squirting water out of the other end there, is we can also make holes on the side like this. And if you made holes on the sides like this and you then push the plunger downwards, what would happen is the water would squirt out from the sides as well as from the bottom, but quite importantly it would squirt out with equal pressure from each of the holes, from the front there and from the two holes on the side. And if you made more holes, water would squirt out with equal pressure from all the different holes, and there's a reason for why that happens. The reason is that liquids are virtually incompressible, and if we were to look more closely at a small part of that, I'm sure you've seen a diagram like this before, but if we were to look at the particles in a liquid, magnify an area there, you can see they're all quite close together. They're not quite arranged in rows and columns like they are in a solid, but they are close enough together so that they are not, the liquid itself is not compressible. These can't be pushed any closer together, and that means that any pressure applied in this system is transmitted equally in all directions. So we use a force over here to create a pressure, and that pressure is transmitted equally in all directions, and we can see that because this water is coming out equally with equal pressure from all directions. And we can use this in a simple machine, a simple hydraulic machine that we call a force multiplier. And as the name says, a force multiplier is a way of multiplying a force so that we can get it to do work for us. Now, how does this work? Well, we need to use a formula, and the formula is very simple. It goes like this. It's given to you in the exam as P equals FA. They do also tell you what pressure, what the P and the F and the A stand for, so it's pressure equals force over area. What they don't tell you are the units. So the units for this formula are as follows. For force, it's in newtons, capital N. Area is in meters squared, and pressure is a new unit that we haven't quite come across yet before, and that's in pascals, and that's written as a capital P and a small a. So how do we use this as a force multiplier? Well, we need some numbers, so let's give a force over here acting in this direction. Let's have a force of 20 newtons and an area of 0.1 meters squared. Let's give an area over this side of 0.4 meters squared, and let's see if we can work out what the new force is over this side. So firstly, let's go back to the right hand side over here. We know that if we apply a force over here, we know that that's going to be transmitted over here. But what actually is that force going to be? Well, what we do is work out the pressure over this side first. So the pressure is force over area. We know the force is 20 newtons. We know the area is 0.1 newtons. So that gives us a pressure of 200 pascals. So the pressure in the system is 200 pascals. Now, how does that help us work out the force over this side? Well, it's a very simple case of using the same formula, but we have a different set of numbers that we can plug in. We now know that the pressure is 200 pascals in the system, so we can say 200 is the force, which we don't know on this side yet, divided by the area, which is 0.4. And if we are good at maths, we can say that 200 times 0.4, that's rearranging the formula there, will give us the value of the force, and 200 times 4 is actually, 200 times 0.4 is actually 80 newtons. And if you look closely or you look carefully, you can see that we started with a force of 20 newtons, and now we have on the other side of this system a force of 80 newtons. So we have multiplied our force. This is a force multiplier, and this is how it works. Now, it might be worth just applying this to an example of where it's used in real life. So what I've got over here is a car hydraulic system. This system is used to lift up cars that mechanics can work on from underneath. How does this work? Well, it works in a very similar way. we have a liquid that's inside these pipes over here, and we have some pistons. I haven't drawn it in over this side. We've got a couple of pistons over here, closed system of liquid, and we have some forces and some areas that we can work with. So what's the force created by the pistons over here that are lifting up the car? Well, in the same as we did before, we need the formula: pressure equals, let's not use red, pressure equals force over area. The force over this side is 500 newtons. The area is 0.1 meters squared. That gives us an overall pressure of 5,000, and you must remember the units, pascals. Now, if we know the pressure over this side, well, we can use the same formula again over here. So we've got pressure equals force over area. We don't know the force, but we do know the area, and we do know the pressure, so it's 5,000 equals force divided by, now look, we've got 0.6 here, but look, we've got two pistons, so this is 0.6 and this is 0.6, so the total area is 1.2, and if we work that out, I do believe that is 6,000 newtons. And the way I got that was rearrange the formula: 5,000 times 1.2, and that gives 6,000 newtons. So we started off with a force of 500 newtons over here, but because of the rules that we've just discussed and the formulas that we've just used, we've now got a force of 6,000 newtons. So a force of 500 newtons is turned into a force of 6,000 newtons, and that force can then be used to lift up our car, so our mechanic can happily work on what he needs to work on. Okay, so that's an example of where it might work in reality. There's the formulas that you can use. Other systems, other examples that you might see it in are car braking systems, and the way that works is, here we've got a car, we're looking from above, these are the four wheels, we've got our closed system of liquid, and this is the brake pedal, and you can just push down gently on that brake pedal, create a certain pressure. That pressure is transmitted throughout the system, but the force is multiplied, so we have a much bigger force than you actually used in the first place on your braking system, and we could work out a calculation similar to what we did over here, but we won't go into that just now. I think you hopefully get the idea. Other systems include mechanical diggers, those diggers you see dig up the road as you're maybe going to school or whatever. Another example is a car jack. Again, inside this system we have a closed system of a liquid with a small force over here working on a bigger area to multiply the force. Okay, so these are just examples that you might see, but the idea is the same. We use the formula pressure equals force over area, and we can use it as we've discussed in the video. That's me done for this video for now. Thanks for watching, and I'll see you again soon.